Section 12.3, inscribed angles. We have two goals for this section. First goal is to find the measure of an inscribed angle. And the second one is to find the measure of an angle formed by a tangent and a chord. So we are going back to what we learned in the last two sections, tangents and chords. But this new thing is inscribed angles. So what are inscribed angles? Well, inscribed angles are, and I might type this instead of write it, so bear with me here. Whoops. An inscribed angle is an angle whose vertex, I can't even type right now, whose vertex is on the circle and whose sides are chords of the circle. All right, so the vertex is on the circle and the sides are chords. So if you look over to that picture down and a little bit to the right, there is an inscribed angle. Continuing on, an arc with endpoints on the sides of an inscribed angle and its other points in the interior of the angle is an intercepted arc. Intercepted arc. So looking at that picture, the intercepted arc would be an arc formed by an inscribed angle. And an inscribed angle is where you have the vertex on the circle and two sides making two chords going to other parts of the circle. So here's something to think about as we're going on today. Angles formed by intersecting lines have a special relationship to the arcs the intersecting lines intercept. We're going to study arcs formed by inscribed angles in this section. All right. So, I am going to warn you there's a few more theorems. We had a lot of theorems in this chapter. There's just a lot of them. So, this first theorem, we'll cover the examples up for right now, but it says the measure of an inscribed angle is half the measure of its intercepted arc. Okay, so to put that into perspective, or into a formula, we'll say the measure of angle B is equal to 1/2 the measure of arc AC. Now remember, arc AC is the same measure as a central angle. That was not real accurate there. But it's the same as a central angle from there to there. So whatever the central angle is, the inscribed angle, which is actually this angle, is going to be half of that. So that's what it would be, half of whatever the angle, the measure there is. So first example, it says find the value for each of each variable. For each circle, the dot represents the center. So right here we're given two arcs. We're given this one arc right here, which is 128 degrees. This one is 134. We don't know them. We don't know this arc right here. Well, we don't know the inscribed angle. So that's what we want to find out. So let's first find the arc measure, because I think we can do that. 128 plus 134 would equal 262, I believe. 250, 262. So those would be, these two together are 262. That looks really bad. Something's wrong with the marker right now, or the calibration. But anyway, I'll fix that later. That means that the remaining arc, which is A, would be 360 minus that 262. I believe it's just going to be 98. But we borrow here, borrow there then. 10 minus 2 is 8. 15 minus 6 is 9, and that would be 0. So 98 degrees. A would be 98. Okay. Now, to find that inscribed angle B, we said it's half of whatever the measure of that arc is. So B would be equal to 1/2 of 98 degrees. So that would be 49. Okay, B would be 49. That angle would be 49 degrees based off of what we learned in this theorem, the inscribed angle theorem. All right, we've got a little bit more going on with this one. So let's look at it. We're trying to find A, B, and C. So we'll put that up here. A equals, B equals, and C equals. So I'm just looking at this first one. We have 48 degrees. Something's 48 degrees here. This arc is 48 degrees. And the inscribed angle would be actually B. That actually goes all the way to a different part of the circle. And I know it looks a little bit unequal, but that's still fine. It doesn't say anything about how it has to look, that the sides have to be the same length. So we know right now that B would be equal to 1/2 of that 48 degree arc. So B is 24. What else do we know? So just to draw that out, that inscribed angle is this one right here with that arc. I see another inscribed angle, angle A. And that arc is right here, arc, which is 144. So A would be 1/2 of that 144, which A would be then 72, or 72 degrees for that one. Oh, and now C has to be equal to, these are, oh, this is great. Good review. We have vertical angles here. So whatever this angle right here, it would be the same as C. And since we have the other two angles in there, 72 plus 24 would get us to 96. So we just do C would be equal to, well, what's 180 minus 96? Borrowing here. 484. So we have that this one right here is 84 degrees. And vertical angles make angle C also 84. Nice. Breaking it down. And thanks to that theorem that we just learned, we found two of them, which helped us find the third. All right, we're going to learn another theorem here. The next theorem is, well, corollaries to that theorem. So there's three of them. And these three corollaries, first one, two inscribed angles that intercept the same arc are congruent. Two inscribed angles that intercept the same arc are congruent. So I think what we're saying here is, if you look right here, this inscribed angle and this inscribed angle both intercept this arc. So those are congruent angles. Even though they're not the same angle, they're going to be congruent angles. Sweet. Corollary 2, an angle inscribed in a semicircle is a right angle. So if this is the semicircle, this is the inscribed angle, it's going to be, that's 180 degree. This has to be 180 degrees up here, because it's half of a circle. So then the inscribed angle is half of that, which is 90 degrees. Corollary 3, the opposite angles of a quadrilateral inscribed in a circle are supplementary. So if we have this inscribed angle, the opposite one would be this one. And they're supplementary because they make up the whole entire circle. Between those two arcs, they make up the whole entire circle. And you take half of that to find the angle measure, so that would add up to 180 degrees. So let's utilize those. Let's do example 3 and 4. And their arc, well, there's another one. But examples 3 and 4. Find the value of the variable for each semicircle for each circle the dot represents the center. So we have 124 degrees here, and that means that this one right here, this inscribed angle would be half of that, which would be 62 degrees. Okay, well, we don't know C yet. All right, so if you look at it, that line that I have in green here is a diameter, goes right through the center. So that means C has to be whatever 180 minus that 124 would be. 180 minus 124. When you do that, I'm not going to borrow right now, it would be 56. So that C equals 56 or 56 degrees. And that means that B has to be equal to half of that because we have an inscribed angle. Okay, so half of that would be angle B, which would be 28, or 28 degrees. And that leaves the third side of that triangle, or if you look at it, it's also dealing with a semicircle. The arc is a semicircle, so that half of a semicircle is 180 degrees. That's a bad 8, but half of that would be 90. So A is 90. It's a right angle right there. Very good. I'd like you to try to do number 4 on your own. So I got these answers over to the right. D and C were pretty easy to figure out because opposite angles of quadrilaterals have to be supplementary. So D would have to be supplementary to that. So D and 92 have to be supplementary, so D is 88. C and 102 have to be supplementary, so C is 78. And then I utilize the inscribed angles formula to find the other two. B would be 112 and C is 64, if my calculations are correct on that one. And this next question, these next two, I'd like you to try on your own. Be prepared for them in class, and those are two that I'd like to go through in class. But I have one more theorem for you. It's theorem 1212, and theorem 1212 says the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So, if we look at the picture here, the measure of angle C, that's right here, if we're looking at this one, or right here, if we're looking at that one, is half the intercepted arc. So it depends on what you're looking at. It would be the arc BDC. So I'm looking at this one, it would be BDC. It would be the same thing, well, I guess we just have it written over on this one, it'd be BDC, it's half of that one. Okay, we've still got the same thing. It works for half, even if it's so half of the intercepted arc, the tangent and a chord would make the same thing as an intercepted arc, or inscribed angle, sorry. So as an example, this is the one we're going to go through here. Number 7, find the value of each variable. So if I look at this, well, 102, I have a tangent and I have a chord here. That means this is half of that. So that angle has to be half of 102, which would mean it's 56. That's not what we're trying to find, though. So let's look in here. All right. We have that this is right here. Again, the line is not drawn correctly, but that's 64. So this is an inscribed angle. So we know that B has to be half of the inscribed angle, which would be 32. That's helpful. 32, sorry. 32. And this is 56, so A and B have to make up the rest of it. Well, do we have an... Alright, so nice thing about this, we have a diameter. So that means the rest of this arc right here would have to be supplementary to 102. So the rest of that arc would be 78 degrees. And it just so happens that the tangent line and this chord make up that arc. So half of that would be C. So C would be equal to half of 78, which is 39. All right. So C is 39, and that means that A would be whatever 180 minus all of that is. So let's just add these up. 56, because that's a line, it add up to 180. 56 plus 32 plus 39, 17. 5, 8, 11, 12. So 127. Hopefully I added that right. 180 minus 127. Bar here, we get 53 degrees. So for A, we have 53. And that's the example we're going to go through for this theorem. So finish it off by looking at these closing questions. think about what you learned. There's a lot in there. Some confusing things, I think. But how can you find the measure of an inscribed angle? And what is the relationship between an angle formed by a tangent and a chord and the arc it intercepts? Okay, so lots of things to think about. So digest that, and hopefully something good comes out the other end. We'll see you next time.